All right, so let's jump right in. If you're a software architect or really any developer, I guarantee you've had this feeling. You're looking at a code base, and yeah, it works, but you just know it's delicate, fragile. It feels like one wrong move, one new feature request, and the whole thing could just tumble down like a game of Jenga.
And that's really the core problem, isn't it? The code gets the job done today, but it's brittle. It's rigid. It fights back when you try to change it. You go to integrate a new library or add what should be a simple new feature, and bam, a whole cascade of problems just erupts. This isn't just a bug. It's a crack in the foundation. It's a structural issue, and that requires structural solutions.
So let's open up the Architect's Toolbox. Today, we're going to pull out 3 classic structural patterns. I don't want you to think of these as some dry academic rules you have to memorize. Think of them as powerful, specialized tools. Each one is designed to fix a very specific kind of architectural headache, helping us build systems that are not just functional, but flexible and way easier to maintain in the long run.
First up, we've got the adapter. Its mission sounds simple, but you will see this thing in action absolutely everywhere. Its whole purpose is to be a bridge, a kind of translator between two things that just weren't designed to talk to each other.
Now here's the really important part. Let's say you've got a component. Maybe it's an old piece of legacy code you can't touch, or a third-party library. It works great on its own, but the problem is its method names and data formats don't line up with what your new system expects. The adapter pattern lets you use that component without changing a single line of its original source code. It's all about making things play nice together.
The travel adapter analogy is just perfect for this. The power outlet in one country is completely different from the outlet in another. Your adapter doesn't try to rewire the wall or rebuild your device. Nope, it just sits right in the middle, translating the connection so that your hairdryer can get the power it needs. That is exactly what a code adapter does for software interfaces.
And this code snippet shows you exactly how it works. So imagine our modern news system expects to call a method named log. But we've got this super reliable, battle-tested old logger class from years ago, and its method is called write-to-log. What do? We create a logger adapter. This new class implements the new logger interface our system wants, but on the inside it holds a reference to the old logger. So when our new system calls log, the adapter just turns around and calls write-to-log on the old object. Simple, clean, and no legacy code was harmed in the making of this feature.
Okay, but it's not a silver bullet, right? Nothing ever is. So what are the trade-offs? Well, on the one hand, it's absolutely fantastic for plugging in old code or third-party libraries without messing with them. You're reusing proven code, which is always a win. The downside, you are adding another class, another layer of abstraction. If you use a ton of adapters, it can add a little bit of mental overhead. So as the architect, you have to make the call. Is that clean integration worth that small cost and complexity? Most of the time, the answer is a resounding yes.
All right, let's grab the next tool from our box. This one's called the decorator. Now this pattern is all about adding new features or behaviors to an object, but here's the trick. You do it dynamically, without ever touching the object's original code. The key word there is dynamically. Instead of creating this rigid, messy family tree of subclasses for every possible feature combination, you just wrap your base object in other decorator objects. Each wrapper adds the new functionality you need on the fly, at runtime. It's incredibly flexible. And the coffee analogy just makes this so easy to understand. Your base object is a plain espresso. Want to add milk? You don't create a whole new milky espresso class. No way. You just wrap the espresso object in a milk decorator. Want sugar with that? You wrap the milky coffee object in a sugar decorator. Each layer adds a new behavior and can even change things like the final cost or the description of the drink. And here's what that looks like in code. The most important thing to notice is that the simple coffee object and all the decorators, like milk decorator, they all implement the same coffee interface. So a decorator takes a coffee object in its constructor, that's the thing it's going to wrap. Then, when someone calls its getCost method, it first asks the wrapped object for its cost, and then it just adds its own cost on top. You get this beautiful chain of wrappers where each layer contributes something to the final result. The biggest win here, by far, is flexibility. You completely avoid what we call a class explosion from subclassing every single feature combination. Plus, it's a perfect example of the open/closed principle. You're open for extension, you can always add new decorators, but you're closed for modification because you never touch the existing code. Now, the downside? You can end up with a lot of really small, similar-looking classes. And let's be honest, trying to debug a long chain of decorators to figure out where a weird value is coming from, well, it can sometimes be a bit of a pain.
And for our third and final tool today, we have the facade. So if the adapter connects things and the decorator enhances them, the facade's job is to simplify. This is your go-to pattern when you're staring down a wild, overwhelmingly complex system and you need to tame it.
So what does that really mean? It means you've got this sprawling subsystem with a ton of moving parts. Think about a video processing library or a complicated e-commerce checkout flow. The facade gives you a single, clean, simple front door for clients to use, and it hides all that internal complexity behind one neat and tidy class.
This is such a great real-world example. When you start your car, you don't care about how the fuel injectors, spark plugs, and battery all coordinate in a precise sequence. You just want one simple interface, right? The ignition button. The car's computer system is the facade here. It takes your simple request and orchestrates a dozen different subsystems to get one thing done. Start the engine.
And here we see it in code with a video conversion facade. Anybody who's ever worked with multimedia libraries knows that converting a video is a messy, multi-step process. You're juggling audio codecs, video bit rates, container formats. It's a lot. But the client code doesn't care about any of that. It just wants to call one simple method like convert video, give it a file and a format, and get a finished video back. The facade is what handles all of that messy orchestration behind the curtain.
The main benefit here is decoupling. Your client code isn't tangled up with the dozens of classes inside that complex subsystem. That makes your whole application much easier to understand and maintain. But there's a danger. The facade itself can grow too big and become what we call a God object, a single class that just knows and does way too much. It's also worth remembering that while it provides a simple path, it doesn't usually block the more complex path. A determined developer can still bypass it and go straight to the subsystem if they really need to.
So, there we have it. 3 tools: the adapter, the decorator, and the facade. But here's the thing. The real skill of an architect isn't just knowing what these tools do. It's developing that gut instinct, that intuition, to know exactly which one to reach for to solve the problem at hand.
And this is absolutely everything. Before you even think about grabbing a pattern from the toolbox, you have to stop and clearly define the problem. What is the real pain point here? Are you trying to connect 2 things that don't fit? Are you trying to add new features on the fly? Or are you just trying to hide some overwhelming complexity? The answer to that question will point you directly to the right tool for the job.
So let's just break it down one last time, side by side. You use an adapter when your core problem is an interface mismatch. Your job is to translate. Use a decorator when your problem is a missing feature or responsibility. Your job is to add new behavior dynamically. And you pull out the facade when your problem is overwhelming system complexity. Your job is to simplify how people interact with it. See? 3 very distinct problems, 3 very specialized tools.
And at the end of the day, that's what these structural patterns are all about. They're not about changing the nitty-gritty implementation details. They are tools for organizing your code, for managing how the pieces fit together, and for creating a structure that can grow and change over time without shattering into a million pieces.
And that's the question that really defines a great architect. When you choose the right structural pattern today, you're not just putting out a fire. You're building a more resilient system, one that's ready for the inevitable, unknown challenges that are just around the corner. Thanks for joining me in the Architect's Toolbox today.